All right, so today we are going to do stoichiometry. In the last class, I finished with the oxides, hydroxides, all of that stuff. So the properties of oxides and hydroxides we did in the last class. Today we are going to do stoichiometry. You guys can hear my voice, right? And see the board clearly, right? All right. So, what is stoichiometry? Stoichiometry is the proportion of reactants and products. A balanced chemical equation can be used to find the stoichiometry of a reaction. You guys can't see my board? We can. Okay. So for the people who can't, you should rejoin. All right. So the first and the most basic stuff in stoichiometry is balancing equations. In the IMAT, they won't give you a lot of complex equations to balance. You can see something like this. You'll find it in your IMAT exam. For A levels, though, there was very complex equations to balance. So uh, nitrogen reacting with hydrogen forming ammonia, very popular reaction. So um, to balance an equation, the first thing is you write the the species in the left hand side. In this case, the reactants are nitrogen and hydrogen, and here I have only one species, which is ammonia, so NH3. So I have two nitrogens and two hydrogens. And in NH3, I can break NH3 down further into nitrogen and hydrogen. And in the nitrogen, I have one nitrogen in NH3 and three hydrogens in NH3. So I want to make, I have to add two here. If I add two here, right, then the nitrogen, now it would multiply by two and give me two. So the nitrogen is balanced, but the hydrogen now, if I multiply three with two, I get six. So I have six hydrogens now. So what can I do to make this six hydrogens as well? So the most basic thing you can do is when a species is alone, when it's only one atom, it's very easy to balance. So I have two, right? I can, if I put three multiplied by two would give me six. So now I have six hydrogens and two nitrogens on the left hand side. So six hydrogens and two nitrogens. And I also have two nitrogens and six hydrogens on the right side. So now this is called a balanced equation. So the first step in answering stoichiometry questions is to balance equations. So um, there are three main equations you need to know for stoichiometry. It's N equals mass over mR, the most basic one, where N is the number of moles, mass is the mass, and MR is the MR. They'll give you the MR or AR, right? For example, oxygen is 16. So the MR of oxygen is 16. So when they say that oxygen is 16, I would multiply 16 by 2 because I have two oxygen molecules. Similarly, if I had CO2, right, and this told me carbon, what's the MR of carbon? Uh, can someone tell me the MR of carbon? Is it 12? And if it's 12 and oxygen is 16. So here 12 plus 16 times 2 because I have two oxygen molecules, two oxygen atoms, sorry. So 16 times 2 because I have two oxygen atoms. And that would give me, I think, 44. Yeah. So this would be the MR for carbon dioxide. So the first step, this was the first equation. Mn is mass over mR. The second equation is N equals V over 24. V over 24. And this 24, remember that it's in decimeter. So this equation, right, N equals V over 24, where V is the volume, N is the number of moles. This is only used when we have gases. When we're dealing with gases, then we'll use this equation. And remember that they won't really always give you the gases, the unit of gas is in decimeters. So when I have a gas which is not in decimeters, they would either give you in decimeters or centimeter cube. So when it's in centimeter cube, right, it's not 24. Instead, it would be V over 24,000, because now it's in centimeter cube instead of decimeter cube. So when I have centimeters, I use 24,000. If I have decimeter, I'd use 24. So this was the second equation. And the third equation is N equals Vc or Cv, where C is the concentration and V is the volume. What's the unit of concentration? It's mole dm -3. And volume is obviously in decimeter cube. So these are the three main formulas. There is one more. I'll get to that. But so I've divided stoichiometry questions into 3 steps. Step 1 is you use the 2 given values to find the number of moles. So you find the number of moles using the 2 given values. They'll either give you mass, or they can give you the volume, and they can also give you concentration. So if you have mass, then you can simply use mass over mr to find the number of moles. And if it's a gas, then they would give you volume, and you can divide the volume by 24 or 24,000, and you'll get the number of moles. So step 2 is you'll do the ratios. I'll get to what ratio is, and then step 3 is you would use that ratio to calculate the answer. So before I continue, right, you have to memorize the polyatomic ions, because these are very important in 2 chapters, stoichiometry and oxidation. Memorize all of these polyatomic ions, and especially their charge, because charge comes very important in oxidation numbers. So sulfate, remember it's SO4 to -2. Similarly, hydroxide is OH raised to power -1. It's negative. So take a screenshot of this, and you have to memorize all of the polyatomic ions. Yeah, memorize them. It's not really like there's nothing really to explain. So yeah, memorize them. So moving on with stoichiometry. What is the Avogadros constant? Avogadros constant is when 1 mole is the amount of any substance containing as many particles as there are carbon atoms in exactly 12 grams of carbon-12. 1 mole of any substance will always contain exactly the same number of particles. So don't focus a lot on this, but there is one unique formula, which is number of particles, right? Number of particles is denoted by capital N. This would be equal to the number of moles, right? What is the number of moles? This number of moles that you just found right here using these 3 equations. The number of moles multiplied by the Avogadros constant, A. And Avogadros constant is 6 times 10 raised to power 23, I think. Yeah, 6 raised to power 23. This value you should memorize. It's the Avogadros constant. And moles times the Avogadros constant would give you the number of atoms or molecules. Right. So, for example, how many atoms are there in 0.25 moles of carbon? Carbon, they told me, is 0.25 moles. I know that number of particles. I need to find the number of particles. In this case, the particle is atom. Remember, they don't usually tell you it's particle. They can either call it molecule or atom or atoms. So in this case, they told me it's atoms. So I have 0.25 moles. I multiply with the Avogadros constant. This is 6 times 10 raised to power 23. So what I get is I multiply this 6 with 0.25. So when I multiply, right? When I multiply, what I get is 1.51 times 10 raised to power 23. So this was my number of atoms in 0.25 moles. So, yeah, here I want to focus on this part. So Particles can be atoms or molecules. Number of particles, as I said, is moles multiplied by Avogadros constant. And you can convert the atoms to moles by dividing the atom by 6 times 10 raised to the power negative 3. So if I had the number of particles, right, and they told me, hey, convert this number of particles into number of moles. So how would I do that? I have the number of particles. I know number of particles is Avogadros constant time moles. So if I want to find moles, I'd simply divide this value, the number of particles, by the Avogadros constant. And what I get is the number of moles. So let's do an example. So how many moles of this is part A, in sodium ions are present? How many moles of sodium ion are there in 1 mole of Na2CO3? So this is another rule that you need to know, that if they ask you the number of moles in a compound, not moles, sorry. If they ask you the number of atoms or molecules in a compound, right, you'd use the ratio method. So they'll give you the empirical formula. Empirical formula is basically the number of all of the elements in the compound. So I have Na2CO3. They're asking me how many sodium ions are there in 1 mole of Na2CO3, sodium carbonate. So 1 mole of Na2CO3. So I have 1 mole of Na2CO3. 1 mole has 1 compound, because the suffix, right? This suffix is 1 only. So this suffix, remember, will simply tell you the ratio. Whenever you're using ratios, you'll always see the suffix. The suffix will tell you how many moles are there of this compound. So whenever you're using ratios, you'll always compare the suffix. So I have 1 mole of Na2CO3 because they said it's 1 mole. And in this 1 mole, how many molecules do I have? I only have 1 because the suffix is 1. So I have 1 molecule of Na2CO3. Compare this. Now you'll use the ratio method. So 1 mole, right? And how many moles are present in, how many moles of sodium are present in Na2CO3? You can see there are 2 moles of Na sodium. So 2 moles, right? And I need to find the atom number. So I don't know what's the suffix or the number of molecules of sodium. I don't know the suffix of this. So I will write this as X and simply cross multiply. So I'll get X as 2. Now this 2 means this is the number of moles or molecules. This is the suffix. So this is confusing, but let's do another example. How many bromide ions are there in 0.5 moles of BaBr2, barium bromide? So I know barium bromide has how many suffix? It has only 1, right? So I write 1 as the suffix. How many suffix do I have for bromine in BaBr2? I have 2. Right? So I write 2 as the suffix. Now I need to find the moles or molecules of bromide ions. So I know that there is 0.5 moles of BaBr2. I need to find the moles or the molecules in bromide. So I write X and simply cross multiply. And I'll get X as 1 because 2 times 0.5 is basically 2 times 1 by 2. This would give me 1. So X here is 1. Therefore, bromine molecules or moles is 1. So this is when you're dealing with particles. And this usually doesn't come up. What you'll usually find in the IMAT is more of the number of molecules, right? So you usually use these 3 formulas the most, mass over MR. So let's do the example of these types of equations. So what mass, this is a question, what mass of barium sulfate would be produced from 10 grams of barium chloride in the reaction. And they'll always give you the reaction, and it would usually be, they'll usually balance it out for you, because you won't get time to balance equations out. So they'll give you the balanced equation. So I need to find the mass of barium sulfate, right? I need to find the mass of barium sulfate. And what is the known product, a known value here? I know that they said 10 grams of barium chloride. Where is barium chloride? Here it is. Barium chloride is 10 grams. So when I have 10 grams, I have the mass, right, of barium chloride. I can divide this by MR and get the number of molecules. So mass is 10. The MR of barium chloride, they'll give you, you don't need to memorize anything. I think it's this 208. Yeah. The MR is 208. So when I find this out, it will give me around 0.05 moles. So this is the moles of barium chloride. And this was the first step. This is step one, which is you find the known value. You use the known value and you find the moles. Step two is you use your ratio method. So I have BaCl2. This is the known. And then I'll use ratio and compare it with my unknown. So my unknown, which I need to find right here, is barium sulfate, right? So I write BaSO4, right? And I compare the suffix. Remember, I'm telling you again and again, you have to compare the suffix, the values that are next to the compound. So in this case, right, in this case, I have 1 mole of BaCl2 and 1 mole of barium sulfate. So the known value is 1, suffix is 1, unknown value, the suffix is also 1. My moles, number of moles, I know I calculated for barium chloride, it's 0.05. So I write 0.05 moles. And now I can find the number of moles for barium sulfate. Why? Because I can simply cross multiply. And the moles of barium sulfate would be 0.05 as well, because the suffix are same. So you can skip the ratio part if you find that the suffix is same. So when the two suffix are same, you can simply copy the number of moles for that. So I have one suffix, it's 0.05. So barium sulfate here would also be 0.05. So what I wanted to find was the moles of barium sulfate. I found the moles, and the question asked me what mass of barium sulfate. So now I need to find the mass. I know the molecule N, right? This is N, it's 0.05. I can use the MR of barium sulfate. The MR, I think it's here, 233. MR is 233. So I would simply move this here, multiply the number of moles with the MR. It's 233, and I'll get my mass. So the mass is 11 grams or 12 grams to simplify. So this is how you would usually find the answer when you have only one known value. This is the case when you have one known value for your reactants. There is another method for a different type of question. That type of question is when you have two known values. You have two known values. When you have two known values, you can't simply use the ratio method. There is another method you have to use. And that method is called access or limiting. So when do you use access and limiting? You use it when you have two known values in your reactants. Right. So let's go to that question. So here is a access or limiting type of question. If 40, and this is the type of question they'll ask you in the exam. If 40 grams of carbon and 40 grams of silicon dioxide is placed in a furnace, what is the mass of silicon carbide? So again, I have carbon and SiO2, and I have two known values now. They gave me the mass of carbon as well as the mass of silicon dioxide. So I have both the masses. Now, in this case, right, what will I compare the values with? Because I have carbon, I can find the number of molecules of carbon as well as the number of molecules of silicon dioxide because I have both the masses present. But what will I compare with for silicon carbide, right? They asked you the mass of silicon carbide. So when I here, right, in this question, I compared my known to unknown. So but I have two known values here. So I can't simply use this cross multiplication method. For this type of question, I will first find the molecules, the moles of both the known reactants. So in this case, first step is you find the number of moles of both the reactants. So the number of moles of carbon is going to be 40 over the MR of carbon. Carbon is 12, right? So I'll write 12 and I get 3.33 moles. This is the number of moles of carbons. Then you find the number of moles of the second reactant, which is, in this case, it's silicon dioxide. So SiO2 number of moles would be 40 over the MR of silicon dioxide. It's 60. And what I get is 0.667 moles. Now comes the confusing part. So in these types of questions, you'll compare the ratios of these two words. Let me explain. So I have 3.36 of carbon. This is the number of moles of carbon. How many moles and what is the suffix of carbon in this case? In this reaction, it's 2, right? So I write 2 as the suffix. 2 suffix or 2 molecules is giving me 3.36 moles of carbon. And then I write the values of SiO2, the second reactant. In this case, the suffix, right, is 1. And the number of moles is 0.667. That's the number of moles I need to react. I need 0.667 moles to react. So how much would react with carbon? I don't know that number. So let me write X as the number. So when I cross multiply these two values, right? So 2X equals 3.36. Then X would be, the value of X is this right here, 1.67. What I get is X as 1.67. So my value of X is 1.67. I need 0.667 moles to react, but I have 1.67 present. Again, step 1 was I found the number of molecules for both the reactants. Step 2 is I find the ratio of two given molecules to see which of these is in excess. So then I found the number of moles of SiO2. I found that it's 1.67, right? When I did the ratio method, I found it's 1.67 right here, 1.67. So 1.67 is the moles of SiO2 that reacts with carbon dioxide. So I have in the question, I have 0.667. I need 0.667. I have 1.67. So SiO2 has 1.67 moles. When I can clearly see that this is the moles that I have. And this 0.67, which I found in step 1, when I divided the mass with the MR, I got 0.667. This is the molecules that I need. I have 1.67. I need 0.667. Obviously, 1.67 is more, so this is considered as the excess. This is known as the excess. So when I have something in excess, right? When I have something in excess, that value would not be used for ratios. I can also do it in another way. Let's say I want to find the number of carbons that reacted. So in this case, I'll write the suffix, right? I'll write the suffix of carbon dioxide, and then I'll write the suffix of silicon dioxide. The suffix in this equation right here, this equation. This equation, Ra. In this equation, I had 2 molecules of carbon and 1 molecule of SiO2. And then I know now I want to find how much of carbon reacted. So SiO2, I know I need 0.677, right? I told you earlier, when I found this moles, this is the moles that I need for my reaction. So the moles of carbon that I need for my reaction, right, is I found right here, it's 3.33. So I need 3.33 moles of carbons to complete my reaction. But how much of carbon do I have? For that, I'll write X, I'll simply cross multiply. And what I get for the value of X is, I get X as, let me do it on my calculator. So 2 times 0.677 gives me the value of X. Give me a minute. 2 times 0.677. What I'm getting is 2 times, I'm getting 1.354. So 1.354. 2 times 3. Yeah, I'm getting the value of carbon as 1.354. I need for the carbon to get reacted, I need 3.33 moles. So this is the moles that I need, right? How much moles do I have? I have 1.354. This is the moles that I have. So this, obviously 1.354 is obviously less than 3.33, right? So this is known as my limiting reactant. In the case of silicon dioxide, right, when I did silicon dioxide, I found 1.67 as my answer. This is the moles that I have. But in step 1, I found that silicon dioxide, I only need 0.667. This is the moles of silicon dioxide that I need. I need these many moles, but I have these many moles of silicon dioxide. So obviously, this is my limiting factor. My limiting reactant is carbon dioxide. Carbon. So is this clear till now, that how I found limiting and excess? Is all of this clear? That how I found limiting and excess reactants? Okay, so it's clear, right? So when I find my limiting reactant, the next step is I compare the moles of the limiting reactant to my unknown reactant, unknown product, what I need to find. So in this case, right, I needed to find, they're asking me find the mass of silicon carbide. So first I'll compare and find the number of moles of silicon carbide. I have the carbon as my limiting. So the moles of carbon, the suffix, right, is 2. The unknown value of suffix is 1. The moles of limiting, the moles, right, the moles of limiting I'll use is 3.33, because carbon, remember, in step number 2, I found it's 3.33. So now I compare my 3.33 with my unknown value. So now I cross multiply, I get the value of moles. I think it would be 3.33 divided by 2. It would be 1.665. This is the value of silicon carbide. This is the number of moles. And finally, I want to find the mass, right? So N is mass over MR. And then I write 1.665 multiply by the MR, right? I'll multiply with the MR and I'll get my mass. So this is how you find the mass when I have two known values in my reactants. Yeah. So let's do a question now. This question. This was from 2017. Take your time, solve the question. We have around 8 minutes left.